Today we're talking in the capacity of electronics and information technology. The Minister with us now live. Mr. Vaishnaw, thank you so much for speaking with us here at NDTV Profit. Always a pleasure to speak with you. And of course, the buzz right now is semiconductors and how you have shown on a whiteboard how it will work. Those videos and that picture has also gone viral. But let me begin by understanding why this is such a big deal, because all through the pandemic and afterwards, the world first learned about how crucial and vital these very little objects are. What we have decided yesterday and what we've done yesterday, how will that lay the foundation to truly be Atmanirbhar on semiconductors?
See, semiconductor is basically a foundational industry. Everything that we use in our houses today, in our offices today, during our travel, everything has semiconductor in it. For example, within the home, starting with your refrigerator, the light, the fan, the air conditioner, TV, mobile phone, going out of the house, the train that you catch or the metro that you catch or the car in which you drive or the bike or scooty, if you travel outside, practically every equipment that we see today, anything that requires a switch on and switch off, every such thing requires a semiconductor in it. So practically this is like a raw material which is required in every sector of manufacturing, whether it is steel making or car making, whether it is manufacturing aeroplanes or manufacturing trains. So this is very, very important for our economy. That's why our Prime Minister, Shri Narendra Modi ji, has put huge focus on getting the semiconductor industry into India. The first policy proposal, which was published in early 2022, after that we kept on working on developing the ecosystem, because it's a very complex industry. It requires thousands of different types of gases, chemicals, consumables to be able to run a fab properly. So we focused on getting the ecosystem, and then came the announcement of Micron, and within 100 days of approval, the construction of the factory started. That gave huge confidence to the world, and yesterday our Prime Minister approved 3 more proposals, 1 fab of Tata and Power Chip of Taiwan, and 2 ATMP units, 1 of Renesas and CG Power, second one is of Tata Electronics. So these 3 projects combined and the Micron project gives us the foundation for setting up the semiconductor industry in India. This will basically cater to our automobile industry, our electric vehicle industry, power electronics, consumer electronics like TV, refrigerator, all these items, to our defense and space sectors. Practically every industrial and domestic application, consumer applications will be benefited by these 4 plants.
So I just wanted to understand the cumulative investment for these plants is 1.26 lakh crores. How much of this will be given by the government as part of the PLI scheme? I'm trying to get a sense of how much we are incentivizing and subsidizing these projects, as of course we need to. World over, the US, etc., everyone is doing it. It's high cost. But what is the sort of a breakup and picture when it comes to this fresh lot of plants?
So we have a very robust assessment process of the project cost. There are items which are admissible as expenditure. There are other items which are not admissible as expenditure. And this is a team of professionals who benchmark everything as per the global best and as per the actual cost which gets incurred. Basis that our policy is 50% incentive is there, and that incentive gets repaid significantly as the industry progresses. It's a very interesting structure and by which this industry gets set up, and our investment which was approved as the program was 76,000 crore. this is the first part of this entire journey. This is going to be a 20-year journey. We have to lay the foundation. We have to make sure that the entire value chain comes to India. We have to make sure that our strong design capabilities, they are further strengthened. The fab comes and ATMP comes. So this entire value chain comes to India. So that's the way with which we are working. It's a very long program. It will take, for the coming many years, we'll continue to get the benefit out of this and continue to grow this program.
What is the outlay you see, sir, in FY25 out of the 76,000 crore rupees? And do you expect it to increase? We will have a full budget after the election.
I won't be able to get into those minute details.
Okay.
Broadly, the 4 units will lay the entire foundation because they bring the entire capability. I also want to point out a couple of more things. First, Northeast is one part of the country where our Prime Minister has put huge focus. More than 50 times he has personally visited. We have highway connectivity, railway connectivity, air connectivity, optical fiber connectivity, and now such a high-tech project is being set up in Northeast. That itself is a very big thing. 27,000 crore investment coming in Assam, and that will again boost the economy of Northeast. Second point which I would like to emphasize here is, today the ATMP technology has got developed in India, which basically gives us a huge capability. It makes us totally at par with the best in the world. And with these 3 projects, the way we have structured these projects, the fab capability also will come to India. The fab between design, fab and ATMP. When we have all the 3 value chain components, and we have the ecosystem, and we have the talent, India becomes the most attractive destination for future semiconductor manufacturing by any company in the world. So this is the way our policy is structured, creating that entire ecosystem, all the 3 parts of the value chain, the ecosystem for all the materials which go in, and the talent pipeline. Combined, all this will lead to, and then once we have the semiconductor industry, the immediate corollary of that is getting the manufacturing industry. For example, laptop manufacturing. For example, mobile manufacturing gets a quantum jump. For example, your automobile industry doesn't have to depend upon imported chips in case of any disruption, right? For example, during the COVID period, we saw the disruption in car manufacturing. That doesn't happen. So many different things fall in place once this basic foundational building block of this large industry is available. That's the way we need to think.
Okay, absolutely, sir. So, this is fascinating because if you look at what the world is trying to do after COVID, everyone realized that they better get, their semiconductor dependability lowered from China, from Taiwan, do their own thing. To my mind, and please explain this because you have, you obviously have seen this very in depth and you are the expert on this. Fabbing is the toughest part. Which India is now also trying to do. We are making progress in the ATMP part, which is assembly, testing, marking, packaging, design. We've always been ahead. Fabbing is the tough one because you need super specialized engineers, you need specialized gases, technology, etc. Give us a sense of that. How much of our focus is going to be on that, and how important or challenging is it to become self-sufficient in fabbing?
That's actually a very, very important point that you have raised. Fab is definitely the most complex. Close to 16,000 items go in making a fab properly running, up and running. Practically, if you look at the periodic table of all elements, practically every element that exists on Earth is used in a fab. And it's very, very complex, very refined process. So, for example, this is a wafer which is manufactured in fab. This wafer, it looks like a small disc, correct? In effect, this is like designing a very complex city on a small disc like this. The fabrication which gets done on this wafer, if you take the tip of the nail 1 lakh times finer, 1 lakh times smaller, that is the dimension with which this circuit is designed on this wafer. You cannot see with your eyes. You have to have very specialized equipment, not even the microscopes that you find in a lab. It has to be very, very specialized equipment which basically prepare the circuit on this wafer. That is fabrication. And it's like building, for example, within this small little wafer, there are 5,000 chips. Now each of this will be very, very small, very minuscule, you cannot see it. Then that is taken out, extracted out, and ATMP is done. So ATMP will basically take this small thing out, and then using a very complex process, that small thing is then converted into a chip. So this small little thing that you see is the chip. And chip can then again be like a multi-story building, right? So let's say a 20-story building. There will be a common lift which goes, there will be plumbing which is there in the entire building, there will be electrical wiring entire building, there will be some floors which are 4 BHK floors, there will be some floors which are 2 BHK floors, there will be some floors which will have parking. So all that complexity is there in a chip. A chip of this size can actually have something like 100 kilometers of electrical wiring. 100 kilometers of electrical wiring. There is cooling system in it, there is heat management system in it. It's very, 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 very complex. That's why only a handful of countries are able to master this technology. So we in India, under our Prime Minister's leadership, are now in a position where the design capabilities are getting complemented by fab and ATMP capabilities. ATMP compared to fab is simpler, but still it's again very complex. As I was explaining, something which cannot be seen with eyes has to be created into a chip like this, a small item, right? So then that chip goes into the circuits. This is a circuit board. So this circuit board then goes into equipment. That is the way it works. So once you have design and fabrication and ATMP, then the natural corollary is that people who are designing modules or manufacturing modules, they will come to India. People who are manufacturing circuits, they will come to India. Then once circuits and modules are there, then people who manufacture laptops, they automatically come to India. So that's the way this entire cycle goes. Yeah. So it's very, very important to first get the foundational things right. And this attempt, very successful attempt of getting 4 units, all of them very, I just wanted to show you a small chip. Chip is like this.
I'm going to ask,
focus on this?
I'm going to ask my cameraman to zoom in on it. Yeah, I'm going to ask my cameraman to zoom in on it. So
please zoom in on this.
Yeah, if they can show it. This is just fascinating, sir. The way we're describing this, we're getting, I mean, for viewers of NDTV Profit, you're getting a live demonstration from the minister himself on how all of it works. And just to imagine billions of dollars of investment to make that one tiny thing that you have in your hand.
It's very complex, very, very complex. It's really complex. That's why only a handful of countries, and we are very lucky that our Prime Minister has very clear vision and a big focus on it, because India attempted semiconductor fab way back in 1962, 1970s, 1980, 1984, 2007, 2011, but all these attempts could not succeed, and finally we have a successful attempt where we are able to get the entire thing in place, the entire value chain in place.
So just to understand further, and thank you so much for, explaining and putting an image to this complex technology. How much of fabrication, I'm assuming that's the full form of when we say fab or fabbing, I could be wrong. How much of fabbing are we going to do as part of our current plan? Is that going to be a smaller portion or a majority of it? I assume that's also what needs the most investment.
You're right, absolutely. We will be doing 50,000 wafers of this type in a month. We'll be fabricating 50,000 wafers of this size in 1 month. That is 300 crore chips in a year. It's quite significant, but I can say with good sense of confidence that because of the clarity of policy, because of the focus on getting the ecosystem in place, rather than pushing the project, making sure that the entire ecosystem gets in place, and the focus on getting huge pipeline of talent. We have tied up with 104 universities where training in semiconductor design and manufacturing and ATMP is being given. We have tied up with international institutes as well as our SCL Semiconductor Laboratory Mohali to train the work floor, the shop floor people, the clean room people. So all those things in place will lead to at least many more projects, at least 4 times or 5 times the investment that we have seen today in the coming 5 years. Because the base is there. See, this is the way world is looking. 10 years ago, most of the industry participants were saying, should we go to India? That was 10 years ago. A few years ago, as the entire policies kept on showing results, people started saying, when should we go to India? Now that the ecosystem is there, people will say, how soon should we go to India? That's the mindset change which is happening.
So I just want to understand that, I mean, I was reading a figure that by 2025, India's demand for semiconductors is going to be about $100 billion. And as of today, we have to import this. Am I to understand that by 2029, most of this will be made in India, we'll start exporting as well? What are the timelines looking like?
Yes, a significant part of our requirement will be made in India. We will also become major exporters, just like we have become major exporters in mobile phones. 99% of our consumption is today made in India in case of mobile. And we have become big exporter, close to $13–14 billion of exports, right? Same story will play out on semiconductors also. We'll become a significant manufacturer, meeting our own demand as well as exporting. Out of these 4 units, the unit in Assam will be exporting to some of the best, most prestigious automobile companies in the entire world, in Europe, in America, in Japan. So that is the kind of the Renesas plant and the Tata Power Chip plant. They will be supplying to some of the most niche and high-tech products like high-speed trains, like defense products, like aeroplanes. So these will be supplying to some of the most important products. They will also be supplying to a large volume base like televisions, like refrigerators, like consumer electronics. Practically every gamut will be covered.
So just last point from you, and I know you're busy, you've given us this time, thank you so much, but I just wanted to get a sense. Now we have 4 plants now. There's Micron, I think 2 by Tatas and 1 CG Power. How many more are we going to have? How many more in the pipeline, or are we now going to wait and see what happens with these 4 projects first?
This is a 20-year journey. This is not a 1-year or 2-year program. Creating a new industry in a country, correct? So our Prime Minister has given us a clear target that we should prepare a roadmap for 20 years. So the way we have structured this entire thing is get all the technologies, develop the technologies, start the R&D process, then move on to designing complete chipset, manufacturing them in India and exporting them, then come to advanced research. It's a very properly laid out 20-year program on which we are working. And we have a very robust team of technical experts. Some of the best global experts are working with us. They are the ones who are evaluating everything. They are the ones who are giving us the right advice. They are the ones who are structuring the entire journey. And these are really very well-renowned names in the semiconductor industry. And luckily, and this is something very interesting, globally, you go to any large semiconductor company, Chief Technology Officer, Chief Production Officer, Chief Procurement Officer, so many times the Chief Executive Officer, they are all Indians. So close to 30% of the semiconductor talent is Indian basically. So we are getting a lot of good support, a lot of good guidance from best brains in the world. And that's why the program is so successful. Clarity of thought at the Prime Minister's level, clear focus at execution level, and extremely good advice coming from best experts in the world.
Just a last question, sir, slightly off topic, but because there has been so much buzz about the telecom sector right now, and one of the players, Vodafone, has recently finally gone in for a fundraise. I just wanted to get your outlook on the sector. Do you see now stability coming in? There is, of course, hope for an investor. Anything that you can comment at this point?
So I prefer never to comment on any company which is listed as a matter of policy because of the responsibility, the position of responsibility that I hold at this point of time. But what I can tell you is, after the reforms that were done in telecom sector by our Prime Minister, and getting most of the legacy issues behind us now, and getting a new Telecom Act in place, at least 8 large investment funds have met me so far, and they want to explore investments in telecom sector in India because the market size is very large, the technological acceptance is very high, our digital India, our India stack basically is so widespread. And that is the gateway to, telecom is the gateway to digital India. So combined all these factors, the investor interest in India is huge. So we will see a lot of investments, we will see a lot of innovations, we'll see new business models coming up, we'll see new technical advances coming up in the coming years.
So I know you will not say it, sir, but can I assume that if there are 8 large investors, Vodafone might see interest from one of them?
I can only say that from our perspective, we'll do everything that is possible to attract more investments in telecom sector.
Fair enough. Thank you so much. Thank you so much for your time, taking all our questions and truly explaining in such beautiful detail what the semiconductor journey will look like for India. Just thank you. Fantastic. Ashwini Vaishnaw there, Union Minister, talking about India's journey to becoming a semiconductor superpower and, of course, a lot more.